welcome back to it. It's Maths Masterclass with Leo. Today we are doing Laplace transform. The Laplace transform, right? Let's do that. So today our focus or our main focus will be on the 3, right? Proving that the Laplace transform of 1 is 1 over s, proving that the Laplace transform of k is k over s, and proving that the Laplace transform of e to the power at it's 1 over s minus a, right? So we will start with the Laplace transform formula or equation, which is the Laplace of f of t is equivalent to the integral from 0 to infinity of e to the power negative st of f of t dt, right? So the first one that we're going to prove is the Laplace of 1, where f of t is equivalent to 1. No, f of t, not f of x. F of t. Okay, so in this case, we'll say the Laplace of, instead of f of t, we'll write 1 is equals to the integral from 0 to infinity of e to the power minus st. Then instead of f of t, we substitute 1 dt, right? And this will give us what? We can directly integrate this because this is 1. Directly integrating this, we will have e to the power negative st over negative s from 0 to infinity, right? Then, I don't like dealing with fractions. I take out the fraction. Then I'll be left with e to the power negative st from 0 to infinity, right? So in this case, this is s, not 8. In this case, we'll have negative 1 over s into e to the power minus s of 0 of infinity, then minus e to the power minus s of 0, negative 1 over s. If I say e to the power infinity, this will give me 0, minus e to the power 0, this will give me 1, and then this will give me 1 over s as my solution, because when I say negative 1 over s multiply 0, it's going to give me 0, then negative 1 over s multiply negative 1 is going to give me 1 over s. Right? We have proved the first one. Let's move to the second one, which is proving that the Laplace transform of k is indeed k over s. Right? This is how you'll prove it when they say prove the Laplace transforms. Right? This is how you're going to do it. Okay. This case, we're proving when f of t is equal to k. So the Laplace transform, instead of f of t, you're going to have k. This is equals to the integral from 0 to infinity of e to the power minus st, then k dt, right? So k is the constant, I can take it out. Then I'll have the integral from 0 to infinity of e to the power minus st dt, right? Then this will give me k into, when I integrate this, I'm going to have e to the power minus st over negative s from 0 to infinity. Then this, I don't like dealing with fractions. I can say k over negative s into e to the power minus st from 0 to infinity. Substituting, I'll have k over negative s into e to the power minus s into infinity, okay, infinity minus e to the power minus s into 0. Negative k over s into, this will give me what? 0 minus 1. Then my solution will be k over s. My solution will be k over s, which is that the second one on the table. Let me just write my k clear. This is k, right? Then the last one for the day, proving that e to the power 80 is equals to 1 over s minus a, right? After proving all of this, we'll definitely do problem solving. After proving all of this on the table that we have, we'll definitely have problem solving questions. Okay, now we want to prove that the Laplace transform of e to the power 80 is equals to 1 over s minus a. So in this case, we will say the Laplace transform of e to the power 80, this is equals to 0 infinity e to the power minus s t, then e to the power 80 dt, right? This is equivalent to k, integral from 0 to infinity of e to the power minus st, right, plus 80. Because the bases are the same, you can just add the exponents, right? Then this will be the integral from 0 to infinity of e to the power minus a, okay, taking out a common factor, okay, just write my s, okay, taking out a common factor of negative, I'm going to have s minus a, close bracket t, dt. Then integrating that, this will give me negative into s minus a e to the power minus into s minus a t, from 0 up to infinity. Then I don't like dealing with fractions, which is 1 over negative into s minus a, right, into e to the power minus into s minus a t, close bracket, from 0 to infinity, right? Substituting, I'm going to have negative 1 over s minus a into e to the power negative into s minus a, then 0, not 0 but infinity, minus e to the power minus into s minus a, then 0 now. This will be negative 1 over s minus a into 0 minus 1. This gives me 1 over s minus a. That brings us to the end of today's lesson. Thank you for watching up to this far. Don't forget to like, subscribe, and share the content with your friends. See you in the next video. Danko!